Welcome to Scalable Machine Learning, and this is our first lecture. Let me share the screen. So in this first lecture, I will introduce you to Spark and also how to do Spark on our HPC. Again, this video will be made available on the YouTube. And in this lecture, we will firstly talk about the big data problem and why we want to introduce Spark, and then some essentials of Spark, and followed by an example of log mining. And finally, we will talk about PySpark and our HPC and other resources. So why Spark? Spark becomes popular basically because of the big data problem. So where does the big data come from? Nowadays, many things, if not all, are happening online. For example, our online activities are tracked by cookies. Nowadays, we need to accept many cookies in order to browse the internet. So many of the activities are tracked, such as clicks and bidding events and your YouTube watching history and so on. And on the other hand, nowadays, there are many user-generated content, right? So both on web, because of the popularity of the internet, and also the mobile internet. So users generate lots of contents on Facebook, Twitter, YouTube, and so on. So we talk about data. So there are basically three types of data structures. The first type is called structured data, which has a schema. For example, relational database and formatted messages. The second type is called semi-structured data. And they are something like schema later. That is, you will have a schema later relatively easily. For example, documents XML and tagged text or media. And lastly, that is the unstructured data, which is labeled as schema never. For example, plain text and our media, such as videos or audios. So let's go into details of these three types of data. The first one is structured data. So a typical example is database. That is relational data models. Okay? So they build on a relational data model to structure a database. And this has been the hottest job about 20 years ago. So when we talk about database, that is talking about structured data. For structured data, they have a schema. This schema basically describes the organization of the data as how the data is constructed. And the programmer has to statically specify the schema. So they need to be specified. And this type of data has been decreasing due to the popularity of consumer and media applications and in enterprise search. And for structured data, SQL, the structured query language, is the standard tool to process structured data. We call it SQL. And then what is semi-structured data? Semi-structured data, they are self-describing rather than formal structures. right? So they have tags or markers to separate semantic elements, right? But they are not formal, right? So, and therefore, the column types actually implicitly defines the schema for the data. So our Spark can dynamically infer the schema when they reading while reading each row of data. And as programmers, we can also statically specify the schema to make it more structured and formal. Examples of semi-structured data include CSV files, which are very popular now, and XML and JSON files. So they are all semi-structured data. And how about unstructured data? Unstructured data has only one single column in the view of the computer, right? So it has only one column of a string or binary type. For example, video, right? So to the computer, video has only one column, right? So it's binary data, right? So it's binary data of string. And for example, music and personal content like a Facebook post. They are all unstructured data. And in 1998, almost 20 years ago, it was said that more than 70% or 80% of all data in organizations are unstructured data. So in order to analyze these unstructured data, we need to traverse the data structure spectrum. We need to go from the right to the left. So what we do is we need to impose structure on the unstructured data. And this is typically done by data warehouse techniques, include extract, that is to extract information from the unstructured data and transform it into a more formal structure, and load, that is to load the transformed data into the formal structure such as a database. And there has been some traditional analysis tools such as Unix shell commands, AWK and grep, but these are all run on a single machine. But this is not adequate for big data. And this is because data are growing faster than computation speed. There has been growing data sources from the web, from mobile, from scientific research and studies. And on the other hand, storage are getting cheaper, and the size is doubling every 18 months. But on the other hand, the CPU speeds, actually they are stop increasing, if you notice, right? So if you buy new computers, you may notice that the clock speed, it relatively stays relatively stable, right? That's very different when I was a student, where every year we see the clock, CPU clock frequency increase, right? So increase every 1 or 2 years, they will just double, right? So, and there are also some storage bottlenecks for a single computer, right? So this is some graph from the internet showing that the CPU speed is stop increasing, right? Stop increasing fast. Then how to solve the big data problem, right? So we know that nowadays for big data, one machine cannot process or even store all the data that we want to analyze. Therefore, the solution is to distribute the data over a cluster of machines. That is, we will have lots of hard drives working together, and we have many CPUs working together, and we will have many memory cards to work together. And that is why Spark was invented at UC Berkeley. Right? So this is the first part. And in the next part, we will talk about the essentials of Spark.